we're asked to solve a trigonometric equation in quadratic form and give the solutions on the interval from 0 to 2 pi, where the interval is closed on 0 and open on 2 pi. We're also asked to give the final solutions rendered to 3 decimal places. So looking at the equation, notice how we do have a common factor of 2 on the left, but other than the common factor, the left side does not factor further, and therefore we'll have to use the quadratic formula shown below. So we'll go ahead and leave the equation in its current form and apply the quadratic formula, where a is equal to 6, b is equal to -8, and c is equal to -6. Also notice how in the formula, instead of x, we will have cosine theta on the left. To save some time, I've already performed the substitutions, where again a is equal to 6, b is equal to -8, and c is equal to -6. Simplifying, we have cosine theta is equal to the quantity 8 plus or minus the square root of 208, all divided by 12. Remember, there are two values here, and therefore we now have to solve cosine theta is equal to the quantity 8 plus the square root of 208 divided by 12, which is approximately 1.8685, as well as solve cosine theta is equal to the quantity 8 minus the square root of 208 divided by 12, which is approximately -0.5352. In order to solve these equations for theta, we take the inverse cosine of both sides of the equation. But notice on the equation here on the left, we should recognize, since the cosine function values are always in the closed interval from -1 to +1, it's not possible to have a cosine function value of 1.8685, and therefore we are not going to have any solutions from this equation. If we do try to enter inverse cosine of 1.8685, the calculator will show undefined, which we will verify in just a moment. And for the equation on the right, taking the inverse cosine on both sides gives us theta equals inverse cosine of -0.5352. And now let's grow the calculator. The first step is to make sure the calculator is in radian mode, which it is. And let's begin by verifying inverse cosine of 1.8685 is undefined. Click Functions, click Inverse Cosine, and enter 1.8685, enter, and notice how it is undefined. So this first equation has no solution. And now we need to solve theta equals inverse cosine of -0.5352 over the interval from 0 to 2 pi. So again, going back to the calculator, we enter inverse cosine, -0.5352, and we're told to round theta to 3 decimal places. So notice how we have theta is approximately 2.136 radians. But we're not done, because we are looking for all the angles on the interval from 0 to 2 pi that have a cosine function value of -0.5352. And we know cosine is negative where x is negative, and therefore we're looking for angles in the second quadrant as well as the third quadrant. The calculator gave us the angle 2.136 radians, which is in the second quadrant. Let's go ahead and sketch that. Let's say it's approximately here. And now we need to work on determining the angle in the third quadrant that also has a cosine function value of -0.5352. To do this, we first have to find the reference angle of the angle 2.136 radians in the second quadrant, because this will also give us a reference angle in the third quadrant. So the reference angle, this angle here, is equal to pi minus 2.136 radians. So going to the calculator, click on the main tab, enter pi minus 2.136, enter. To 3 decimal places, we have 1.006 radians. So the reference angle is 1.006 radians in the second quadrant, but for the angle in the third quadrant that has the same cosine function value, the reference angle will be the same of 1.006 radians. Notice to find the angle in the third quadrant, this angle here, we take pi radians and then add 1.006 radians. So theta is also approximately pi plus 1.006 radians. Going back to the calculator one last time, pi plus 1.006 radians, enter, to 3 decimal places, is approximately 4.148 radians. So the given equation has two solutions in the given interval. The two solutions are approximately 2.136 radians and approximately 4.148 radians. I hope you found this helpful.